Hi. So in the last video, we have derived the quadratic formula for the quadratic equation. This one, ax square plus bx plus c is equal to 0, where a is not equal to 0. So the formula for finding the root of the variable x was this. And we have derived this formula by the method of completing square. So now we will explore this formula. Let us observe this. So as we see, there is a term under the radical sign of the square root. There is a term b square minus 4ac. So this term b square minus 4ac, that is, which is under the square root sign, this is known as the discriminant. And we define it by say capital D. So this is your discriminant D. Now why the name discriminant? As because the value of this term, that is value of D, will determine or discriminate about the nature of the roots of the quadratic equation. As you see, there is a plus minus sign before this D. Or let me write down now this formula in some modified form: minus b plus minus under root the discriminant upon twice a. So I have written in the simplest form, where d is this term, discriminant. Now as you see, the d, this has to be positive, because any number under square root negative is not possible. Not possible in reality. Therefore, if the value of this discriminant comes out to be negative, we say that there will be no real root, because this under square root, any negative number under square root is not possible. So that's why. So that is the thing, and so we can say if the value of d is less than 0, means negative, then we can say that there is no real root. No real root of the quadratic equation, this. However, if d is greater than 0, then we'll get some value, real value. So again, if d is a whole square, then it will be rational, and if d is not a whole square, it will be irrational roots. So again, that is, but however, so because of this plus minus sign, we will be getting two real roots, two distinct. That means that, so it will give two distinct real roots. And what will be the roots? As you know, the roots will be, one will be minus b plus root d by 2a, and another will be minus b minus root d by 2a. So two distinct roots, because of this plus minus sign, we will be getting two distinct real roots. Actually, they are conjugate of each other. That is also okay. So they may be rational or irrational, depending upon whether d is a whole square or not. So these two conditions I got. And thirdly, if d is equal to 0, then what will happen? You see, if 0, then this part will vanish. So in that case, the root will be minus b by 2a. So, or we can say, because we are getting two distinct roots or unequal roots because of this plus minus root d. Now when this term will not be there, so we can say the roots will be equal, or we can say we get equal roots. Equal roots, or actually one root, only one value minus b by 2a, which will be equal to, x will be equal to minus b upon 2a. Minus b by 2a. So since it is a quadratic equation, it will have two roots. and so both the roots are equal, so we say equal roots, or we can say one value of the roots. And in this case, two distinct roots are actually this one. These are the two distinct roots. And when d less than 0, no real roots. So these three conditions, 1, 2 and 3, this observing or verifying, checking this condition, will be able to tell about the nature of roots of the quadratic equation without solving it. So this is a very important term, that is a discriminant d, which determines or discriminates about the nature of roots. So let us see the applications of this. So let me take one question, first question. Let me take the equation from a NCERT book, exercise 4.4. That is the equation, quadratic equation is 2x square minus 3x plus 5 is equal to 0. I have taken this equation. Now I have to find the, without solving, I have to tell about the nature of roots it will have. So for that I have to check this condition. So for that I have to find the value of d. And what is this? So let me first find out the values of the coefficient. So what is a here? A is coefficient of x squared 2, b is coefficient of x minus 3, and c is the constant term plus 5. So we have got these values of the coefficient. Now we are in a position to find the value of the discriminant, which is your b square minus 4ac. Put the values. B is minus 3 whole square minus 4, a is 2 and c is 5. So it is 9 minus 40. So obviously it is negative, minus 31. So it is less than 0. So the first condition, less than 0. So therefore we say this equation will have no real roots. So we conclude this without even solving, because that is very important to check this condition before solving a quadratic equation. So when it will have no real roots, so there is no question of solving. So this is the, okay. Now let's I'll take another question. Next one. Let me take another equation. So I take this from the second part. 3x square. Equation is 3x square minus 4 root 3x plus 4 is equal to 0. This is the equation. So again let us write down the values of a is 3, b is minus 4 root 3 and c is 4. Okay, comparing with the standard ones. So the value of the discriminant, b square is minus 4 root 3 whole square minus 4, a is 3 and this is c is 4. So 4 for 16, 3 are 48. Minus again this is 16, 3 are 48. So it is coming out to be 0. So is the second condition. Since sorry, this is the third condition. D is 0. So therefore you say the equation will have equal roots. Equal roots. And also we can find out the value of equal roots, that is, so the roots will be equal to, which are roots are equal to minus b by 2a. So minus b is your minus 4 root 3 by 2a. 2a is 3. X square, 2x square minus 6x plus 3 is equal to 0. This is the equation now. So a is 2, b is minus 6 and c is 3. Okay. Now let us put the values in the discriminant expression. So what is the value of d? b square minus 6 whole square minus 4a is 2 and c is 3. So it is 36 minus 24. So it is 12. D is 12, so it is greater than 0. So the second condition, that is if d is greater than 0, so it will have two distinct real roots. So we say the nature of roots will be, it will have, this equation will have two distinct real roots. And what will be the value? These two real roots. These are the two real roots. So I can write, and the real roots are x is equal to minus b plus, okay, let me write out in this way. Actually, these are the values. Minus b minus minus plus, so it is 6 plus root d by, so root 12 by twice a. A is 2 into 2. Or d is minus root 12 by 2 into 2. So root 12 is, root 12 is your 4 3s are 12, so it is 2 root 3. So I can write 2 root 3 here. Instead of root 12, I can write 2 root 3. Root 3 as root 12 is equal to this. So by simplifying, I can take 2 common. So this will become, when I take 2 common, 3 plus root 3 by 2 into 2, so it is getting cancelled. So 3 plus root 3 by 2, and the other will be 3 minus root 3 by 2. So these are the 2 distinct roots. So this is the importance of the value of discriminant, where by checking this condition we can tell about the nature of roots. Okay. Okay. Now let us solve this question. Find the value of k for the quadratic equation 2x square plus kx plus 3 is equal to 0 to have equal roots. So okay. So how will you do? We'll be using the discriminant concept. So you see, for any quadratic equation to have equal roots, so the condition was that d will be equal to discriminant, that is d will be equal to 0. Let me write down in this form: minus b plus minus root d upon twice a. So this was d. So we can do in this way. For equal roots, d is equal to 0. That is the condition. That means, that is what? D is your b square minus 4ac. b square minus 4ac is equal to 0. This condition will be satisfied for equal roots. So let us use this concept. So in the equation, what is a? A is 2. So let me write down. A is 2, B is k, and C is 3 from the equation A, B and C. So what will be this value of D? So D is equal to B square is your k square minus 4, A is 2 and C is 3. So it will be equal to 0. Or we can write or k square minus 24, 0, or k is equal to 20, sorry, k square is equal to 24, therefore k is equal to plus minus under root 24. So whenever I take square root, always give this plus minus, it's very important. So plus minus 24, 4 6 are 24, as you see, this is your 24 actually. So this 2 square into root 6. So I can write 2 into root 6. 4 6 are 24. So this is the answer. So there are 2 values of k. Actually, you should find the values of k. 2 values of k, 2 plus 2 root 6 and minus 2 root 6. Okay. Next. Okay, next question. Next question. The sum of ages of 2 friends is 20 years. 4 years ago, the product of their ages was 48 years. Is the situation possible? If so, find their ages. Okay. So that means first of all we have to check whether this given situation is possible or not, whether it is possible in reality or not. So for that I have to form the equation first, then I will check the value of the discriminant, but that will decide whether it will have real roots or no real roots. So first let us form the equation. So sum of the ages of 2 friends 20 years. So let the ages of the friends be x years and y years. So let ages of friends be X years and Y years. Okay, these are the two variables I've taken. So according to the question, the sum is 20, so X plus Y is 20. The first equation. And next condition, 4 years ago. So the product of their ages is 40 years. So 4 years ago, the age of the first friend will be X minus 4 and age of the second friend will be Y minus 4. So their product of their ages 4 years ago is this one, and according to the question, this is our 48. Okay, so now we'll simplify this, and since our quadratic equation is in one variable, so we'll try to convert into one variable. How is possible? From equation 1 I can use the substitution method, that is I'll replace y. Y will be what? 20, x go to that side, 20 minus x. So if I use this or substitute this, it will convert into one variable, that you know. So it is x minus 4, in place of y write 20 minus x minus 4 is 48, or x minus 4 into 20 minus 4 is 16 minus x is 48. Now let me keep in the form, that is if I put a minus sign in front of it, that is x minus 4, and if I put a minus sign, so it will go inside, x will become plus, it will become minus. So x minus 16 is 48. So this, why I have written 16 minus x in the form x minus 16, so that I can use the identity, because I know the identity, that is x plus a into x plus b is equal to, what was the identity? X square plus sum of the constant a plus b into x plus product of the constant. So this is a very important identity, algebraic identity, that you come across in 9th class, and whenever you come across this kind of product of this kind of expression, we don't open term by term, we directly use the identity. So what will happen, you see, so we can, using this we can write, or we can do one more thing. Since there is a minus sign, I can take this to that side, so this will become plus, and this side will become 0. So I am taking to that side, so it will become plus x minus 4 into x minus 16 plus 48 is equal to 0. Because it is going to that side, 40 is remaining the same side, so it is plus. So now I can use that this identity, so this will become, or you can write, or okay, let me use this one, let me write here, let me erase all this to show you the thing. So what I've got, x minus 4, this one I'm writing x minus 16 plus 48 is equal to 0. Okay. So this, then further I can use the identity, so it is, or x square, now sum of the constant a plus b x. Mine a is a minus 4 and is minus 16. So minus 4 plus minus 16 is minus 20. Minus 4 plus minus 16 minus 20 x. Then product of these two, minus minus plus, and 4 into 16 is 64 plus 48 is equal to 0, or x square minus 20x plus it is 112 is equal to 0. So I got a quadratic equation from the given condition in the question. After here, I have to now check whether the situation possible, means I have to check whether d is greater than or equal to 0. If the discriminant is greater than 0, then there will be real roots, and if discriminant is less than 0, there will be no real root. That is the basic discrimination. So I have to find out the value of a. So what is a? Value of d, sorry, discriminant. So what is a? A is here 1, b is minus 20, and c is 112. So this is the expression for d. So let us find out the value of d. So Therefore D is equal to B square minus 4AC. B is your minus 20 whole square minus 4AC. 4 into A is 1 and C is 112. B square minus 4AC, that is the discriminant. So what is the value of D then? 400 minus 400 and into 448. So it is minus 48. So the value of D comes out to be negative, less than 0. So we write, since D is less than 0, therefore no real root. And that is, this equation will have no real root because of this condition. So hence we say no real roots means this situation is not possible. So answer will be, is the situation possible? We will say no, because of this condition. Okay, that's all for today. Thank you.